Hi, welcome everyone. We'll get started in just a few moments. Okay. Welcome everyone. My name is Sarah Carr, and I'm Chief Knowledge Broker for OCTO, Open Communications for the Ocean. And we're very happy to have you all here for today's webinar on global tracking of marine megafauna space use reveals how to achieve conservation targets. Just a little introduction about OCTO. OCTO is an NGO that connects ocean professionals to the knowledge and networks they need through our webinar series and our MPA help, EBM help, and ocean plastic list communities. OCTO also provides custom consulting services. So I'm going to, in just a second, I'm going to turn this over to Kayla Ripple and Nate Fedrizzi of the Pew Fellows Program in Marine Conservation to introduce more about today's webinar and our wonderful panelists today. But before we do, I want to encourage everyone to participate fully in today's webinar. You are muted, but you can participate through the chat and the Q&A. The chat is available for all of you to send information to the rest of the people, everybody in the webinar. So it's both to the panelists and as well as other attendees. And we encourage you to introduce yourself and post anything that you're interested in sort of community feedback on or post useful information in the chat. Please keep it on topic and professional. But for the Q&A just goes directly to the moderators and the panelists. And we'd love for you to post any questions that you have for the panelists there. It's much easier for us to moderate from the Q&A. And if you had wanted both input from the panelists and the rest of the participants in the webinar, you could go ahead and post it to both of those things. But please do post questions for the panelists in the Q&A. Okay, thank you guys. And now I'll turn it over to Kayla and Nate.
Awesome. Thank you, Sarah. And thanks to Octo for having us here. We're really excited to be here today, and thanks to everyone for joining us as well. My name is Kayla Ripple, and I'm a Principal Associate for the Pew Fellows Program in Marine Conservation. For those that don't know us, the Pew Marine Fellows Program, or PMF, as we like to call it for short, awards fellowships annually to mid-career scientists and other experts around the world to advance knowledge and innovation in marine conservation. Currently, there's more than 40 countries who are represented by a community of over 200 fellows. And in March, we're very excited to announce 7 new fellows that will be joining the community. So definitely stay tuned. You can learn more about us and the fellows we support at pew.org. And Nate will be dropping a link to that in the chat. Speaking of Nate, I'm also joined today by fellow colleague Nate Fedrizzi. He's an officer with PMF, and we'll both be dropping links to resources in the chat throughout the webinar, but he'll also be moderating a panel discussion at the end of the presentation. So for today, we're very excited to be sharing the outcomes of a project led by 2020 Pew Marine Fellow Dr. Anna Sequeira with Australian National University and MegaMove. Anna's fellowship aimed to understand where marine megafauna move throughout the ocean and how they use this space while they're there. She worked with hundreds of researchers to compile available tracking data of different megafauna groups and species like sharks and rays, sea turtles, seabirds, and marine mammals. And last year, with over 300 co-authors, she published a paper in Science detailing these results and offering recommendations on how this information can be used to achieve conservation targets in the future. PMF also published a blog recently about how these findings can connect with larger conversations, and Nate will drop a link to those in the chat as well. So I'm going to let Anna get into the details of the research. But for us at PMF, we're really interested in how these findings can help decision makers, managers, and community members make more informed decisions around planning and implementation of ocean protections. So with the High Seas Treaty having now gone into force and the 30 by 30 deadline nearing ever so close, this conversation is timely and very pertinent to so many audiences. After Anna's presentation, we'll do a short audience Q&A about the research, and then we'll jump into a panel discussion around implications for both policy and management moving forward. And for that part of the webinar, we're really excited to have both Mark Erdmann, who is the Shark Conservation Director with Rewild and also a 2004 Pew Marine Fellow, along with Liz Karan, who's the Director of Ocean Governance at Pew Charitable Trust, joining us to dig a little deeper into this conversation and topic. That will also be followed by audience Q&A, so please do share your questions in the Q&A panel. I'll be moderating, or I'll be keeping an eye out for those, and then at the end can read the questions aloud for panelists to answer. A reminder real quick, just to submit it in that Q&A panel. We're moderating or looking at the chat as well, but your question is more likely to be seen and answered if it's in the Q&A panel. And another reminder that this webinar is being recorded. We'll be sharing the recording with everyone who registered afterwards, and we'll also be posting it to Anna's Fellow directory page, which Nate is going to drop a link to in the chat. So feel free to forward this to your colleagues and networks who might be interested. We would love for you to help us get the word out. If you have any other questions after the webinar or want to get in touch with us, please do reach out. My email is on the slide here in front of you. And with that, I think I've covered everything from our end. So we're going to go ahead and get to the good stuff and get started. And I'll turn things over to you, Anna. I believe you can share your screen now.
Thank you very much, Kayla. So if you just let me then share my screen to make sure we can get started. Can I get confirmation that the screen is on?
I see it.
Yeah, looks perfect. Great. Thank you so much. And hi, everyone. Thank you so much for attending this webinar. It's a real pleasure to get to share the results of my Pew project with everyone. So the presentation is about global tracking of marine megafauna space use and how that reveals how to achieve conservation targets. And we're talking specifically about the targets from the Global Biodiversity Framework adopted in December 2022, which has as the first goal to halt human-induced extinction of threatened species, and two specific targets: one, to bring the loss of areas of high biodiversity importance close to zero by 2030, like Kayla said, very close, approaching really fast. And also by 2030 to get at least 30% effectively conserved, particularly in areas of high biodiversity importance. And this has been now complemented with the High Seas Treaty that just came into force last month, where the objective is to create marine protected areas in international waters, focusing still on this protection of 30% of the oceans by 2030. So particularly my focus in this context is on the large species in the ocean that do large migrations as well. So this includes whales, sharks, seals, penguins, turtles, sirenians, which include dugongs and manatees, flying birds, and so the species that travel very large distances in the ocean. And one of the reasons why I'm particularly interested in these species is because a third of these, I'm calling them collectively marine megafauna, a third of marine megafauna are currently threatened by extinction. A lot of this is due to human-induced threats that lead to changes in space use and disorientation, blunt trauma, laceration, amputation, entanglement, ingestion, suffocation, starvation, and death ultimately. So what is happening is that we're observing declines in the populations of these species, and these are a lot due to a plethora of threats that are taking place in the ocean. You can see some examples on this slide here for threats that already have global footprint, and that includes fishing threats, plastic pollution, shipping intensity, global warming. It also includes noise and a lot of other threats. But the important thing is that these threats are happening collectively. So in the center map here, you can see what we've done, putting those threats together to show that's actually not anywhere in the ocean anymore where there's no human threats that are relevant for these species. And the interesting thing and the most challenging thing about this is that these threats are dynamic in space and time. So they change in space and time, they occur with different intensities in different locations, and very importantly, they occur simultaneously with each other, and then they are also concurrent with animals that are themselves moving through an already dynamic ocean. So this really highlights the complexity, a layered complexity of understanding the overlaps between species and human threats and how this results in impact. So the vision was to create a worldwide movement that involved the community of animal trackers, particularly marine animal tracking, to then bring data sets together, particularly data sets on movement of animals. Because these threats are so dynamic, we really need to understand how the animals move through it, these particularly migratory animals move through this space. So it only makes sense to understand this by using movement data as well. And so the idea is to bring it together so we understand how the animals use space, so we can then understand to which extent they are being impacted by these threats and also where. And that was actually the key for my Pew project. So my Pew project focused specifically on advancing global conservation of marine megafauna. And I had 3 key objectives. The first one was to establish MegaMove as a global scientific project that involved the global community of marine movement ecologists, so that together we could create a unique standardized tracking data set for marine megafauna across taxa. The objective was to bring together as many species and across taxa as possible. And then use that data set to identify global, ecologically and biologically important areas that would reveal the importance across taxa as well. So rather than focusing on single taxa or particular species, we wanted to sort of see how it looked like all together. And then use that information to understand the overlap of those important areas with existing anthropogenic threats. And so MegaMove was indeed created. The year after I received my Pew Fellowship, it got endorsed by the United Nations Current Decade for Ocean Science. And our slogan is tracking our global heritage. And this pretty much serves as a reminder that these species move through entire ocean basins across jurisdictions. So they do not belong to countries or to people, or they are actually a common good. So they belong to all of us. And so it is our responsibility to conserve these species as well. And because these animals move through so many different countries, MegaMove was only possible by collaboration with a lot of researchers around the world. So we have a network of almost 400 researchers from almost 300 institutions from 49 countries. And this entire group is guided by a steering committee that is led by myself, together with 7 other researchers from around the world as well. And so together we are trying to move this scientific program forward to really understand how human activity affects these animals, and particularly now in the context of the conservation targets, how we can use the data that are already in existence to inform how conservation should proceed. Of course, one of the first things we needed to do was to assemble the tracking data sets. And with that came a huge amount of work associated with standardizing the collation of those data sets. So having hundreds of people sending data sets through meant that we needed to create a framework to make the work a little bit more effective. So the way it all started was by asking people to provide 3 simple data templates. So just CSV files as simple as possible, where people included information that was specifically requested about the tagging device they used, about the deployment details specifically, about the species, and then also the people that were involved in the fieldwork. The experience we gained from bringing all these data sets together led to the development of a global standard framework for doing this work at scale that was then published in Methods in Ecology and Evolution. And that's what's summarized in this slide here, with the main objective of focusing on efficient data collation, usage, and sharing. That has clear benefits for the data owners themselves, because there's a huge amount of work just from collecting the data. There's ethics approvals, there's permissions, there's extraordinarily expensive gear that needs to be purchased, and then people need to be in the field. There's a very specific skill set for this, so there needs to be some clear benefits for people who are actually providing the data and people who know about these species, and then of course focusing specifically on preservation of data into the future as well. So really important to have the standardization sorted as we move more into this global aspect of bringing these types of data sets together. So after all that work with the standardization, we did assemble all the data, and the result is a stunning visualization of what life at sea looks like. So in this slide here, you can see an animation of how the species move through the ocean. You can see differences in speed between seabirds compared to other species. That includes polar bears, turtles, the sirenians I mentioned, manatees and dugongs, seals, and more. It's really exciting to see how these animals go about their lives in the ocean, and it also serves as a global reminder of what's at stake when we fill the ocean with our activities that lead to threats to these species. So once we had all this data assembled, the focus was to then try and understand how to achieve conservation targets, and that's what led to the publication that came out in Science, which is the theme for the webinar today. This science paper was co-authored by the almost 400 researchers that we have in our network. And just as a note, I know the paper is behind the paywall, but we do have a link for open access. If people want to access the paper freely, they can go through our MegaMove website and look for the news that released the paper. The link in this news actually provides free access to the paper. So feel free to get the paper there if you are interested. So what I'm going to try to do today here is really summarize what we've done in this paper. And I was thinking it's a very, very complex paper, so I was thinking about the best way to do it. And I think the best way is to focus on the 5 key things we did in this paper. The first one was to really show the coverage of the data set that we assembled. So this slide summarizes the number of individuals per 1 degree grid cell across the entire global ocean. And you can see that the global ocean is mostly covered. So we covered about 71% of the global ocean. And you can see the number of individuals in different areas, with the lighter areas showing close to 1,000 individuals that have been tracked passing through those grid cells. We have the same type of output per taxa, because this was all done, of course, at the species level. To show the results of the paper, we needed to aggregate everything, which was also the objective. But if you go through the details and the supplementary information, there's information all the way to the level of species as well. So you can see here how the number of individuals tracked for the different taxa that we considered, 8 different groups. So we have really good representation for many of these taxa groups, particularly taking into consideration the geographical ranges of each of these animals, which are of course very different. And so the second thing we've done was to use this data to then understand how they use this space. And we try to compile this in corridors, so areas that the animals use to move through as a migration, when they are moving faster to connect different locations, or residency areas, which would be areas that they use for residential type of behaviors, which includes resting, mating, feeding, breeding, and so on. So this slide here provides a summary of what we call important marine megafauna areas. And I'm going to guide you through this, the caption of this figure here, the labels, so that we can sort of use this as we move through the next slide. So in green, you can see all the areas used for residency across all taxa. And in orange, you can see areas that are used as corridors across all taxa. And then there's this outline in blue, which basically represents where residency and corridors overlap. So those areas are used for these both types of behaviors across multiple species. So you can see the outline as areas where the orange could also be seen, but of course we can't see the 2 colors at the same time. So it just shows that there's areas that are used for both behaviors, whether by the same species at different times, or by different species, or by different taxa. And then in gray, you can see areas that were used, that we were able to track animals moving through, but we did not identify any specific behaviors that we were looking for that would fall in this category of corridors or residency. And then areas that are clear with the light blue is areas where we do not have tracking data. Okay, so just to give you a quick overview. So having this output in terms of IMEGs, what we then was to try and understand how they actually use the space in terms of area used, the fraction of area used in each of these behaviors. So here, the color scheme is exactly the same I just explained. And you can see that globally, looking at all species together, more than 60% of the area used was used in important behaviors. Remember, this outline blue is both orange and green. So all this, about 60% of this entire area was used in important behaviors, and about 34% it was used by the animals. They moved through there, but we did not identify a behavior. When we tried to split these behaviors within inside or outside EEZs, we found that about 60% of these important behaviors took place in the high seas. And most of this was outside existing MPAs. And so, of course, this was done across all species because that was our main interest to summarize this. But you can see here how this varies per taxa group. And you can see that the trends are very similar, with the exception of some species, for example, polar bears and sirenians, which are very coastal species. So, of course, they tend to occur more within the EZs compared to other species. Having done this in terms of area use, we also did the same in terms of time, the time the animals spend in these behaviors in the same regions. And so what we found was that globally, about 90% of their time is spent on doing these important behaviors. So even though they use in 66% of the area, they spent 90% in those areas, 90% of their time. And it seems that they spend most of the time within EZs as well. And this particularly translates into more residential behaviors within EZs compared to more migratory behaviors within the high seas. That's why they spend less time in the high seas. They're moving faster through the high seas. And then again, similar output, most of this time is spent outside existing MPAs. So the current MPAs really only cover about 7.5% of the area the animals use, and about just under 14% of the time the animals spent in these important behaviors. So there's a lot of opportunity here to increase protection in areas where the animals are actually doing these important behaviors. So the fourth thing we did was to then, if we know what are the important areas for these species, now this can be used to answer the question, where do we place the 30% protection? And here it's important that I highlight that the color scheme is used a little bit differently. So in this case, the orange is all the important areas we found, excluding the areas that we saw the animals move through but did not find an important behavior. So all the orange here is the areas of the ocean where we know there's important behaviors across taxa. The blue, the dark blue, includes the existing MPA. So you can see the overlap here is not huge, and I already showed you the numbers in the previous slides. And in this case, the green that is shown on top of all the important marine megafauna areas is an example of how we could select up to 30% of the area for protection. So this is an example that includes specifically the areas that was used by more individuals or to do most across both corridors and residential behaviors. And so the result shown in this map is basically an empirical result directly obtained from the data itself. So what we've done in the paper was we did these calculations based on the movement data, but then we replicated this in exact output using model data. So you can see the map on the bottom here is based on modeled results. So we used models to predict where the important marine megafauna areas would be. So the information is not so attached to the data set that we assembled, but actually could be used more generally. So focusing on the patterns observed in areas that are used for important behaviors. And then we use the highest probability of being an important marine megafauna area to create another way to select the 30% protection. So again, the green shows that highest probability of being an important marine megafauna area in the global ocean. And you can see that the patterns are indeed quite similar, even though there are differences. So it's interesting to see that, areas in the North Atlantic clearly include areas that should be protected, whether that were detected whether empirically or through modeling. The same in the Northeast Pacific, very similar in the Central Indian Ocean. Some areas of the Southern Ocean clearly are areas that are of high importance. And then there's areas that are also quite relevant, for example, around Australia, where we have quite a lot of already marine parks and protected areas specifically. When we use model data, we can see that these areas come up as more important, even though we did not have that much tracking data set around it, just to use this as an example. So this gives us a really good idea of how we can move about selecting important areas in the ocean for protection if we are to aim at this biodiversity targets to specifically conserve areas of importance for these species. And the final thing we've done in the paper was to try and look at the threat intensity. And I want to highlight here that this was done just as an average in the paper. Of course, there's a lot of work that needs to be done to dig into the dynamic layers that I mentioned at the beginning of this presentation, but to highlight that the highest intensity areas on average are pretty much within all of the important marine megafauna areas. So it's really important to understand that when we create a protection, what we are going to focus on. So we can focus on areas that are more important for the species, but we need to take into consideration the threats that need to be alleviated in that area as well. So a big important result from the paper is that by increasing marine protected areas by 30%, we can indeed significantly reduce the threat intensity within important marine megafauna areas. So it's, of course, a huge opportunity to create the protection needed for this species. Talking about threats, it's also important to understand how vulnerable the species are to the different threats. So in a different study that came out also last year and also includes more than 300 co-authors, not necessarily just movement ecologists in this case, across the board, experts in marine megafauna. And this study was led by my PhD student, Michelle van Compernol. She looked at more than 200 species of marine megafauna and specifically their vulnerabilities to 23 at-sea threats, all within the categories of the threats that I mentioned: fishing, shipping, pollution, and climate change. She used the IUCN framework to look at timing, severity, and scope of the different threats. And so, long story short, the threats that have the largest scope across all taxa seem to be temperature extremes and plastic. But when we start talking about severity, we really start seeing those fishing threats coming up, particularly longline fisheries and fixed gear. And shipping seems to be a high threat, mostly for a particular group of taxa, including animals that spend a lot of time at the surface, like cetaceans, turtles, or species like whale sharks that spend a lot of time at the surface as well. So importantly is that because the 30% of protection does not include all the important marine megafauna areas that we identified in the science paper, mitigation strategies are needed to be implemented alongside that 30% protection to safeguard IMEGAs, so the important marine megafauna areas that will not be covered by MPAs. So just to wrap this all up and bring it all together, a quick summary of the work that was done included the realization that a third of marine megafauna species are now threatened with extinction, and more than 75% of the areas they use for important behaviors now overlaps with human threats that lead to impacts on these species. MegaMove assembled a huge team around the world involving hundreds of researchers, and together we put together the largest tracking data set for marine megafauna specifically, so we could understand how the animals use the ocean. And then based on that, we could find that 66% of the space they use is used for critical behaviors. This is where the migratory behaviors or residencies or both simultaneously, and the planned 30% protection will, at best, if the areas chosen for protection are focused solely on marine megafauna species, which we know it's not going to be the case, but if that was the case, at best we would protect 40% of all the important marine megafauna areas that were detected. This means that about 60% are still going to be left unprotected. And this is why the final message is that in addition to the planned protection, which of course is going to be a huge step in the conservation of these species, mitigation strategies also need to be implemented to really try to address the conservation target of halting human-induced extinctions and conserve marine megafauna. And there's several mitigation strategies that are already, there's already evidence that they work for protecting this species, for alleviating the impacts of threats. And there's just some examples on this slide here. Of course, there's a long list of these. But for example, applying fishing thresholds and specific standards in operations that might include shifts in gear, modifications to gear, might alleviate some of those threats outside marine protected areas. Developing wildlife and sheep traffic separation schemes and specific slowdown areas might help a lot with reducing ship strikes. And then, of course, promoting international cooperation in global agreements, including UNCLOS and now the High Seas Treaty, will also be essential to move protection forward. So I wanted to highlight before I leave you that this work has been done with a huge number of people around the world. So I really wanted to make sure those people are highlighted in this talk. So a big thanks to everyone. And without them, this would not have been possible. So thanks for collecting the data. Thank you for sharing the data with me. And thanks for helping to share the outputs of this research as well.
Thank you, Anna. That was a great presentation. Oh, yay, we made it to the end. I wasn't sure how long the scrolling was going to take for all the collaborations and to answer my question. We finished. We're good. Okay, so we have a couple of questions in the chat, specifically around the research that you just presented. So I want to ask those before we get into the panel specifically. I do want to acknowledge that I did see some questions about how the current administration could potentially impact this kind of work, as well as other things like the United Nations and hitting their biodiversity targets and some of the goals there. Those I think we might get to during the panel discussion itself, but because those are more towards the policy side, I'm going to save those for the end of the webinar and use this time to focus more on the research side of things. So our first question in the Q&A is referring to something that you may have already talked about in the in your presentation. So if you want to pull your slides back up when I read this question to like walk through that a little bit more, that would be awesome. But this one is talking about how many marine megafauna species are found in the existing MPAs. And if that proportion is greater or less than the proportion of MPAs in the ocean. So how many marine megafauna are you seeing move through existing MPAs? Is that proportional to the number of MPAs that, or the current percent that's protected through MPAs in the ocean?
Interesting question. I'm not able to answer exactly how many species across the ones that we tested. We used data for 111 different species across the 8 taxa groups that I mentioned. So I don't have the details about how many are in there. I have the maps that show the areas that they use. So if the person asking is familiar with the movements of the particular taxa they are interested in, they will be able to see that in the paper, and they will definitely be able to see that in the supplementary information. But the important message is that it's very little of the area they use and very little of the time they use is actually spent there. So how many species seems a very specific question that does not really translate into, I guess, usefulness in terms of conservation. So, you know, we might have individuals from that species that pass through an area that is currently protected, but doesn't do any important behavior there, for example, or at least I need to say this with a pinch of salt. All behaviors are important. When I'm talking about important behaviors in the context of this paper is the behaviors that we were specifically looking for. So something that we can associate with the migration or with the residential behavior along the lines of what I explained during my talk. So the key message really is that not much is actually used in the current MPAs, and that is a huge opportunity that is missed. The placement of those MPAs was, of course, done for different reasons, not specifically focusing on protecting marine megafauna species. So that's probably the reason why there's not much overlap there. If there was some intention of protecting marine megafauna species, would have been a particular species and not necessarily across the range. So I think, yeah, the key message really is not so much, and the key question is not so much how many species pass there, but actually what the protection means for the species.
Mm-hmm. That's great. Can you talk a little bit about how you engaged with so many different collaborators, particularly the methodology that you used to compile such a substantial amount of data sets? And also, what were some of the challenges that you experienced with that process?
Yeah, that's a very good question. I do get that question a lot. Really, I tried to find as many people I could. So obviously through networks, asking people to let me know who are the other people that might be interested in being part of this study, and try to figure out even just a list of email addresses that I could just start to reach out to. I did quite a lot of paper searching and looking at the addresses, email addresses on the papers, so that I could create the emailing list. And then I sent a call out to everyone. To be honest, I thought not many people were going to answer at all, but it turned out quite differently, and it was very exciting, of course, to see. I think I must say a lot, and I don't know the answer in terms of why people got engaged this much, but I think it was because we share the same goal. I think the goal that I presented about bringing this idea forward, coming together to do this study, to understand what species are doing and across taxa at a level that no single group could do, I think that was a common goal, and I think that's the reason that led to people getting engaged with this. And then, of course, there were a lot of challenges from there. So this was just the start, was just people wanting to collaborate. And then, of course, collecting the data was a huge hurdle, because the data are collected in completely different ways. People have different formats they store the data in. And so that's what led to the standardization paper that was published soon after I started this process, because I realized, this needs to be done a lot better. So I tried to sort of put together the learnings I had got from the exercise I was doing to share with people, so that other people can do it better than I did. So there was a lot of work involved in there. And then communication is another big hurdle, because it's really hard to communicate with 400 people in a way that allows everyone to be heard, and that allows me to respond to them as well. So it's a tricky situation. I try my best, and just basically try to make sure that people have time to reply. One of the things is that most of these people are in the field a lot, so it's actually hard to get a response from them, because they are doing the really important work that it's needed for this type of analysis. So there's a series of challenges there, but I think overall it's really about wanting to do this. It's about finding a common ground, things that can be common across people that work with different taxa, because their perspectives are very different as well, and that comes back in the feedback. So I guess the main thing is look for something that it's a common ground, and something that people are willing to do but are not necessarily going to do themselves or within their groups. I hope this provides some answer.
That's wonderful. Thank you, Anna. We have a lot of really great questions in the chat, but I want to make sure that we have enough time to get to the panel discussion. I'm going to ask one more that I think actually leads really well into some of the things that you all will touch on in the panel discussion. And this one actually came in through the chat from Gabriella. Gabriella asks, how do you deal with areas that are data poor but ecologically important and under threat? And how do we avoid falsely classifying them as low importance just because the data are insufficient?
That's a really important question, and it's something that we try to address by adding that layer of modeling into the paper. So the data that we obtain and the main results that we obtain that are sort of empirically obtained from the data, from observing the data and understanding what the animals are doing in different areas, will include areas that have more individuals, that have more tracking data. So that's why we went that further step to actually try to use a predictive framework to basically understand the patterns that existed in the data and how animals across excuse me, across the different species and across taxa, the patterns of their selection of areas to use for important behaviors, and then use this in a modeling framework so we could predict where those important areas might be. And so, as I mentioned during my presentation, it was very interesting to see that those were similar, but there were clear differences in the areas, particularly when we do the predictive modeling. There seems to be a more consistent sort of continuous areas that are important because, of course, we use environmental variables that the animals could be using as cues to do certain types of behaviors. So that's how we try to address that question. The other one was we actually selected only 30% of the 70% covered by the tracking data set we had. So this means that in total is actually about 21% that we are selecting as important areas, allowing space for new data to come in and reveal those important areas elsewhere. So whether new data might not be available yet, and that's actually one gap that needs to be addressed in the future, or there's data that are available in different places that we just weren't able to reach the person that had the data, unfortunately. And so there might be areas that are actually well represented with data, but simply didn't make it to the database we are using. And thirdly, there's a lot more data, even from the people that are part of the MegaMove network, because people obviously did not give me their entire data sets. And also this was done in a particular point in time. So there's a lot more data that has been collected since then that would serve to inform these results as well. So for example, an update of this result once we have a larger database that includes areas that are not currently sampled. So I showed in my map, there's some areas, particularly in the Central Pacific Ocean, for example, huge gap in the MegaMove data set. So once that type of data can be incorporated, then we can have another assessment, an update of this assessment.
All right, I am going to turn it over to Nate now. So that we can get to the panel discussion and dig a little deeper into this. And there will be time at the end for more audience Q&A. So keep the questions coming.
Thank you.
Thanks, Kayla, and thanks, Anna, for a great presentation. My name is Nate Fedrizzi, and I'm an officer with the Pew Fellows program at the Pew Charitable Trusts, and I'm excited to be moderating today's panel discussion. On the panel, Anna will be joined by Mark Erdmann, Shark Conservation Director at ReWild and Executive Director of ReShark, who is also a co-author on this research, and Liz Karan, Director of Ocean Governance at the Pew Charitable Trusts, who led Pew's efforts to help secure the High Seas Treaty. Welcome to you all. We're thrilled to have you here. Just a quick reminder to the audience that we'll move into additional Q&A with the panel at the end of the discussion. So please feel free to submit any questions as they occur to you in the Q&A tool. And with that, I'd like to kick things off with a question that may be on many of your minds after Anna's presentation, which is to both Anna and Mark, based on your research, which areas of the high seas should we prioritize for megafauna conservation?
Do you want me to have a go first?
Yep. Sure. Why don't you kick things off? Thanks.
Okay, yeah. So in terms of areas of the ocean that should be protected, I mean, that question is tough because, you know, we should protect as much as we possibly can, specifically in this context of 30% protection, which is the current target. and specifically focusing on the results of the study that came out in June last year, it's clear that there's areas specifically in the North Atlantic, sort of the central North Atlantic, and then areas in the West Atlantic, and also areas in the East Atlantic, very specifically, are clearly important areas. Some areas in the central South Atlantic, really important as well. Central West Indian Ocean, really important areas there, including the Mozambique Channel, some areas around South Africa, and off the coast of Northeast Africa as well. The Northeast Pacific Ocean and sort of the US coast on that side, really important. And then specific areas in the Southern Ocean, including the Antarctic Peninsula and a few other areas, are clearly coming up as important, whether through the data, empirically through the data, or through the predictions. So I think based on this work, and again, the selection of important areas can happen in many different ways. So it depends on the objectives that are taken into consideration in addition to marine megafauna. So of course, that is a decision that decision makers will need to make. But in terms specifically from marine megafauna, a step forward could be focusing on areas that are both identified as important, whether through the data or through the predictions, and use that as a starting point for establishing the protected areas.
Thanks. Mark, would you like to chime in?
Sure, I'm happy to give some thoughts. Recognizing that while I know that the Pew is very interested in the high seas MPA concept, you always have to have a contrarian scientist, and I guess I'm that one in this case. So we'll let Liz talk at much more depth about that. But I guess I would highlight that one of the key results that Anna found, that our study found, is that while marine megafauna do use pretty much most of the ocean, actually they spend the majority of their time in EEZs. And you know, with a lot of work that's going on using these same data sets, for instance, I'm a shark and ray scientist. There's been a lot of work by the IUCN Shark Specialist Group to designate what are known as important shark and ray areas using also the satellite telemetry data. And what we can see is that there's still a heck of a lot of work to be done within EEZs as well. There's a lot we can do to improve marine megafauna protections within EEZs. And I think probably even Liz would agree that it's easier to do MPAs within EEZs than outside. Maybe she would disagree. We'll hear that more in a minute. So from my perspective, I do a lot of work in Indonesia. We've had some great success stories where we've been able to use the tracking data from manta rays and whale sharks to designate new MPAs there within the EEZ. So I think that there's lots and lots of those coming up now with the important shark and ray areas, and that's just one of the taxonomic groups. I think if you jumped into the turtles and the whales and the seals and stuff, you'd get much more. So if I look simply at the idea of the high seas MPAs, one which is very clear is the Antarctic Peninsula really does need to be focused upon. And there's already been a proposal for that since 2018, which continues to be blocked by two members of CAMLR. And I think that is a bit of a warning as to what ends up potentially happening with these high sea MPAs. Of course, we do have the Ross Sea MPA in Antarctica. That's a great example of a success. But the Antarctic Peninsula is in dire need of protection, and that keeps getting blocked. So anyway, that's a bit from me. I'm sure Liz will have some more commentary.
Thanks, Mark, and thanks for raising the importance of habitats within EEZs for megafauna. Liz, I'd love to bring you into this from a policy perspective. Do both those recommendations from Anna and Mark's comments align with the priority areas that you've been thinking about, and what other factors are you considering?
Yeah, absolutely. So I did pop in the chat. Pew did a report a number of years ago now, back in 2020, looking at a number of different biological criteria to help identify indicatively where the first generation of high seas marine protected areas could be. And what I was excited to see is that there is actually a lot of overlap with the areas that Anna's research has identified. And one of the challenges we faced when we were doing that report and analysis was the lack of data on highly migratory species and megafauna, especially from a large data set like this. So it would be really interesting to kind of go back, and something that we've been thinking about, the need to go back to that report and methodology and incorporate new data sets, updates to the existing layers that we've had, but then also potentially adding on layers such as this to get a more complete picture. And I think, to say that the data sets that we did use were looking more at benthic habitats and structural features as biodiversity proxies, as well as actual biodiversity on the seafloor. But we, as was indicated, and I think many of the participants of this webinar know, there is a lot of maybe not by time, but by spatial area, a lot of use of that high seas by highly migratory species and megafauna. And I think one of the things that will be a challenge for the high seas treaty moving forward and the proposals is how to build in those, how to make sure that the MPAs are designed to take those migratory species and their usage of the water space into account. And that's an exciting challenge. And I think, Mark, to your comments, the High Seas Treaty has a lot to learn from what the domestic experiences has been. There is decades of experience creating creating marine protected areas at the very local level or the national level. Many lessons, both good and bad, what can be done. And as you scale those into the high seas, it does become more complicated. Monitoring, data gaps are potentially more frequent. Monitoring becomes more expensive. Enforcement is a big question as to how that would come forward. But that shouldn't be a reason not to move forward, right, with the protections. And so, especially with what we know about the threats facing these species and the threats facing our ocean and the planet, and how important a healthy ocean is for human livelihood as well as planetary health. So, maybe to pick up, because I do have a soft spot for the Southern Ocean, because before working on the High Seas Treaty, I did work on some of the protections leading into the Ross Sea MPA. We did not, for our analysis and report, look at the Arctic or the Southern Ocean, and that was more by policy design, because there are other bodies, the Convention for the Conservation of Antarctic Marine Living Resources, CAMLR, that manages and has the ability to create high seas MPAs in the Southern Oceans. One of the only other bodies that can do that, create those kind of protections in the high seas. And then the Arctic Council and the Fisheries Management Closure there was another governance structure that is able to manage certain threats. So we were looking at the other areas, but absolutely think that the Southern Ocean protections are important. And maybe to note, one of the lessons we did learn from the policy side was, and we're able to bring forward into the countries were able to recognize and bring forward into the treaty, is the need to have a voting mechanism to move away from consensus-based decision-making, so that we don't have a situation where one or two countries can block really important progress that the majority of countries are looking to move forward with.
Thanks, Liz. Now I'd love to spend some time talking about area-based targets. And so, panelists, in your view, how much of the ocean do we need to protect to ensure the survival of megafauna species? And is 30% protection of the high seas enough? Anna, you touched on this in your presentation, so I'd like to start off with you.
Thanks, Nate. Yeah, the question, if the question is how much we should protect, I think the answer to that question can't be different from we should protect everywhere, to be honest. These animals should be able to do okay without us impacting them everywhere they go. But of course, that's not realistic. And so we're now looking at a target of protecting 30% of the ocean, which is a huge step in the right direction. So my perspective is that we should aim to protect areas that are meaningful, areas where these animals do important behaviors, areas that connect the areas where they do the important behaviors specifically, particularly residential behaviors. And perhaps a way to look at this, which is actually a strategy we use in the paper, is to focus on those areas that have the highest probability of being an important area across taxa, across behaviors. So basically getting more bang for our buck, right? So trying to focus on the areas where we know these animals go and they're doing important behaviors critical for their survival. Of course, I also understand that the selection of marine protected areas will have a lot of other components to it. So perhaps something that could be done is to complement the work that was done now with marine megafauna with the work that has been doing for a long time in terms of all those other habitats that Liz was just mentioning, the important reasons to select areas for protection, and put them together and look where's the overlap, and then focus on those areas as a starting point. From maybe this might be too much of a scientist approach to it, but that's what to me makes sense in terms of making this actually be worth it. Because of course we can tick the box for 30% of the ocean being protected, but then is it in areas that are going to actually make a difference? So I understand the challenges. I understand that these areas of the ocean are used by multiple stakeholders. I understand that it involves billion-dollar industries and people's food and livelihood and wealth and prosperity and all of that. So I understand that there's a large level of impacts besides the impacts on the species that need to be taken into consideration. But if we are to actually address the conservation targets, then we should focus on areas that are important for the animals and the environment.
Thank you. Liz, would you like to jump in on this one?
Yeah, I think mainly to say, the things that are notable about Target 3 of the Global Biodiversity Framework is that it says at least 30% of the global ocean. So I don't interpret that as 30% of the high seas necessarily. I think we need to take a more holistic approach into what Anna is saying, is look at where there is need and for protection of particular habitats or particular species, again, going very much to the conservation objectives. I think the exciting thing about the high seas and the new BB&J High Seas Treaty is that outside of the areas of the Arctic and the Antarctic, which I mentioned earlier, for the first time now we have a tool that can create high seas MPAs. And so it is a new space and a new opportunity to address threats to biodiversity in areas beyond national jurisdiction and create high seas MPAs. And so I think there's an excitement around the new, but that doesn't replace the very important efforts that countries also need to undertake in their own waters.
Thanks, Liz. On the topic of MPA design and MPA network design, you mentioned that most existing MPAs were created to protect specific habitats rather than highly mobile species that are using the water column. And I'm curious if all of you could comment on how protections for megafauna might look different going forward. Mark, you mentioned important shark areas. I don't know if you want to jump in first on this one.
Sure. I mean, I think that obviously marine megafauna have the potential to move vast different distances and cover huge areas of space. But again, as the paper shows, actually a huge percentage of their time is spent within EEZs. And indeed, if you look at many of the animals that we classify as marine megafauna, they're coastal. A lot of them just are. That's really the way they are. And of course, there's some very clear exceptions to that. But I think what we saw looking at a number of different sharks and rays. I'm sorry, I'm in the airport. Hopefully this isn't going to. Can you hear the announcement going on? Apologies. No, I'm going off to do some satellite tagging, and hence I'm in an airport. So I think that traditional MPAs, as we know them within EEZs, can absolutely function for marine megafauna. They have to be big enough. You're not going to work some of the small scale community-based MPAs that have been set up throughout Southeast Asia, for instance, are not going to be big enough to really do much for marine megafauna. But when you start talking about MPAs that are at the scale of 300,000, 400,000 hectares up to 1 million hectares, that actually can do a lot in terms of the percentage of time that the animals spend within them, particularly when they're doing feeding aggregations, spawning aggregations, mating aggregations, turtle nesting beaches, et cetera, et cetera. So I think, it's not that we have to really necessarily do hugely different things to protect megafauna. We just have to bring them into account as we're looking at making some of these, and I'm speaking specifically about more EEZ coastal MPAs. They absolutely, our standard tool practice or toolbox will work. We just have to know where we're supposed to be putting those. So.
Yeah, and maybe if I can jump in on that, I think, again, it's a exciting opportunity in the High Seas Treaty. Ecological connectivity is one of the issue that was discussed very frequently in the negotiations, and it is part of the indicative criteria in the annex of the agreement. And so looking at that from not just looking at that from a connectivity within EEZs. So how can based on these migratory pathways and usage spaces, how do we make sure that marine megafauna, and this is true in any MPA, that they don't run it, that they don't fall victim to threats outside of the MPA boundaries. And so I see that the opportunities of the High Seas Treaty is really just an ability to potentially expand that area and make sure that there is that connectivity that takes into account the highly mobile species as well.
Thanks, Liz. Anna, I'd love to hear your thoughts on MPA design for megafauna protection, and also if you have any reflections on dynamic MPAs as a management option.
Yeah, so of course, I agree with what was just said by both Mark and Liz. It's important that they are placed in places that matter. That's the key. That's the key. I guess the underlying solution, I guess. But it is also important to highlight a couple of things. So the fact that it's a marine protected area means not necessarily that everything is protected and nothing is happening in that location. There's different levels of protection that can be attributed to a protected area. And I think that's where the question gets really interesting, because you might have areas, and in the map that I've shown, those blue areas, they are all classed as protected areas, but threats still happen through there. You saw my map of threats. They are not going around existing MPAs. So I think the key thing for protection really is to establish protection. It's to actually create thresholds and limits of what happens within the MPAs, wherever they are established, but actually own it. If you are creating a marine protected area, then create the protection for everything that occurs in that space, from benthic to pelagic to whatever is important in that particular area. So I think that's key, and it's important that people understand that just because it's a marine protected area, it doesn't mean that there's no fishing in there. It doesn't mean that there's no shipping in there, and even less, it doesn't mean that there's no plastic pollution, or there's no noise pollution, or there's no climate change. So all these threats still occur within currently existing marine protected areas, of course, to some different levels in different areas with different degrees of protection. So I just wanted to highlight that. So I think the key thing is to actually, if you mean protection, or if we mean to create a protected area, then let's own it and be clear about that protection, and take it, particularly if the human activities that take place within those areas are threats that impact biodiversity. So we should use that as the first step. And then to touch on your second point in terms of dynamic MPAs, of course, dynamic MPAs, particularly in the context of what I was talking about today, all of this is dynamic. The threats are dynamic, the species are dynamic, the ocean is dynamic, everything is happening in a very dynamic way. So it makes a lot of sense to move towards dynamic protected areas. So in theory, yes, I think dynamic protected areas would be the way forward. However, and this might be my misunderstanding, so I apologize in advance if anyone knows this better than me or if things don't happen in the way I understand them. But my understanding is that even current static MPAs are not working that well. So the level of management and enforcement needed for a dynamic MPA to work well is just, I think, light years ahead of what we are doing currently. So perhaps, even though that is the direction we should be going towards, perhaps let's try to do static MPAs well first and select them in places that matter. And then once that is established well, we can then start addressing the dynamic component. There's so many levels when we start thinking about dynamic protection, from where the protection should be at different times and spaces, how does that, the dynamics of change of the protection itself to the dynamics of enforcement of that protection. And particularly if we're talking about the high seas, who's going to be there to enforce? How do we have the methods needed to enforce the protection that it's needed? So I think there's a lot of questions that need to be answered first. But of course, we should be moving in that direction. That's sort of my view.
Thanks, Anna. Now, dipping back into the science for a bit, I'd love to talk about some of the technology that made this research possible. So I guess, Mark, maybe let's kick off with you. If you could walk us through some of the tools behind this work and maybe touch on some of the emerging directions in development in animal tracking more broadly.
Sure. Thanks a lot, Nate. So I guess I won't claim to be an expert on all of the different taxa and the different types of tags that were used in the study. But in general, we're talking about satellite tags, what are known as colloquially as satellite tags. And in all cases, those tags, which have a wide variety of different methods of attachment to the different animals, if you think about the different animals included here, and that in and of itself is probably a 2-hour discussion. In all cases, they have to be both recording data and then sending data back to us. And that's where we're going to see some of these really interesting advances that are happening. In the case of recording the data, obviously for those air-breathing animals, whether they're birds or marine mammals or turtles, they're on the surface a lot. They can access the GPS network, which is up there, and we can quite easily track them horizontally. For some of the sharks and rays that don't breathe and don't necessarily come to the surface, that becomes a much harder thing. And that limits what we can get from them because you can't receive a GPS signal underwater. Now, on the other end of that data has to be sent back to us. And up until very recently, we've used what's known as the Argos satellite network, which is a wildlife tracking network. That's how all of this data gets back to us. That used to be, for a very long time, based on only 5 satellites that were circling the Earth, which means that depending upon where you are on Earth, there were very frequently times when animals might come to the surface and be pinging away, but there were no satellites to hear them. And what we're seeing now, fortunately, the Argos network has just expanded dramatically with the addition of 21 new Kineas satellites, came online in July of 2025. And that is massively increasing the number of hits that we get, the number of position data that we can get from an individual tag. So Anna's study covered tag data that went from 1985 to 2018. And it's only in 2025 that we have this vastly expanded network of satellites up above. So I can assure you that when Anna starts doing the re-analysis of the data, there's going to be a massively increased amount of data that's out there, which is a great thing for us. I think also there's all kinds of things going on with the tags themselves. Obviously, there's miniaturization, which helps and means that we can now start putting tags onto shark pups and even smaller birds. Battery is always a huge issue with satellite tags. And nowadays, some of the satellite tag manufacturers are putting in actually solar panels into their tags so that they can kind of go continuously. You can imagine with for instance, a turtle, that would work quite well. And some of course, the batteries are getting smaller and smaller, so we can now look at potentially tags that can go for 2 or 3 years, which is amazing compared to what we had before. And I think we're also starting to get into seeing some of the animals that we didn't think we could tag before or didn't think that we would get much data out of, we're starting to learn about. So obviously those air-breathing animals, they're all potentially satellite taggable. But when it comes especially to the sharks and rays and the other fishes, you know, generally speaking, they're not necessarily on the surface. Obviously, great whites, whale sharks, manta rays are, and so we have lots of satellite tag data from those. But as we've started to delve into it, we've learned that more and more of these sharks actually are on the surface more than we thought that they were. And while that might not be a lot, now that we have lots of satellites circling the Earth, it means that a shark that only comes up for maybe a grand total of a minute and a half per day, we can suddenly get actual satellite tag data from them. So I think that there's going to be a massive change in what we're able to tag, and we'll get much more accurate positions in terms of where these animals are, as well as, of course, the vertical side of thing, the diving behavior, which is yet another one that this paper doesn't even touch on. So all very interesting developments, I reckon.
Thanks, Mark. That's fascinating and very good news for the future of animal tracking. Before we run out of time, I would love to get all of your perspectives on MPA effectiveness, which is obviously critical to area-based conservation, but is often overlooked. As we've been discussing, location matters, but so does how these areas are implemented and managed. So, panel, how can high seas MPAs be designed and managed, in your view, to deliver the greatest benefits to megafauna species? And Liz, let's kick off with you.
Yeah, sure. So I think one of the key things really is making sure that the behaviors and of megafauna and that is incorporated into the MPA design from the outside at the outset. So this goes into and incorporating them into the conservation objectives of the MPA. So you know, it's not just to create a protected area for the sake of drawing a line on the map. It's what are the conservation objectives that you're trying to achieve within that specific area, and making sure from the surface to the seafloor, the comprehensive management plan is put into place that correctly identifies what are the threats that are impacting on that. And then in the high seas, much like within national waters, you know, whether the different international agencies, regional bodies, management authorities that need to be brought on board and consulted on, and ultimately help implement the management measures that will help achieve those conservation objectives and protections for those megafauna species. So I think that's really one of the best things that can be done from, you know, from the very start of the process, building them into the design.
Thanks, Liz. Anna, Mark, would you like to jump in?
Okay, so I can have a go. Yeah, I think the effectiveness really is linked with what I was mentioning before. It's about understanding what the protection actually means and what is the level of protection that is being attributed in the particular area that is selected for protection. So this is beyond the where, like you said, we've been discussing the where, but really how to, once we decide where, how to make it effective. And I think thinking through how to alleviate the threats in the MPAs, you know, and if it's, say, for example, fishing closures, what type of closures? Are these closures within a particular breeding season or within a particular timing that it's more relevant across the species? Because of course what I've shown in my paper is the spatial component, but there's a temporal component to all of this, in addition to the depth component that Mark was just mentioning before. So the layers of complexity keep appearing, but directly relevant to where is when. So I think that's another very important consideration. And when I'm talking about when, I'm not talking specifically about dynamic MPAs, but I'm talking about the thresholds and the limitations that will occur within static MPAs as well. So this is something that can be played with to alleviate the threats on the animals or the impacts on the animals, but also alleviate concerns for impacts on key stakeholders and industries. That obviously will have an impact if their activities are to be curtailed somehow. So from my side, I think that's an important point that needs to be well measured and taken into consideration.
Thanks, Anna. We do want to leave time for audience Q&A, so I think we'll probably move into one of our last questions here for the panel. but I'd love to get all of your thoughts on what's ahead and where you see your work going next as it relates to high seas conservation. I guess let's kick off, Anna, with you. What's on the horizon and what should we be keeping an eye on in this space?
Thanks, Nate. From my perspective, and as a scientist and moving the work forward in that direction, in a scientific direction, really is understanding those layers of threat intensity and how dynamic they are and how they vary in time and space in terms of how they affect the species that are also moving in time and space. So I'm very interested in going a little bit deeper into understanding the impacts with the temporal resolution. That's something that hopefully I'll be able to complete relatively soon. And then, thinking through that in terms of space and extension as well, is to try and understand eventually the potential impacts at depth as well. So things, for example, when we talk about climate change, there's a lot of impacts that we are able to understand at the sea surface in terms of increasing temperature. But then there's also other things that are happening, for example, deoxygenation, which tends to be a bigger problem at depth. So, the animals are, for example, living in a habitat that is now becoming constrained between hot temperatures at the surface and low oxygen at the bottom. So their area of use is actually getting squashed somewhere in the middle. So it's a really interesting effect from a scientific perspective, and probably quite worrying because there's not much we understand at this stage from that perspective. So I think work in that direction is also really relevant.
Thanks, Anna. Mark, do you want to jump in? What's next for your work?
Yeah, I think I already kind of hinted at it, but as I said, there's some big changes in the technology available to us with satellite tracking, and I'm really enjoying playing around with a lot of these new tools, trying to help develop new satellite tags, which allow us to look at species that up until now we haven't looked at, as well as to get much better data out of some of the species that have been typically quite hard to get. So, as I said, there's a lot on the horizon there, a lot of happening on a monthly basis that way. So I'm pretty excited about that. I would just comment one other thing on the enforcement side of things for high seas MPAs. As much as there's a lot of challenges to high seas MPAs, I think the one thing which does give me hope from the perspective of enforcement is that if you compare it to a coastal MPA, which is something I've spent my career working on trying to do enforcement in, there's an enormous plethora of actors that are busy doing things. When you get into the high seas, there's really industrial fisheries, and then there's shipping. And those are the two that we're going to be able to, plastics and climate change, you're not going to control with MPAs, but the shipping and the industrial fisheries potentially, and eventually if there does happen to be high seas mining, those are things that we control. And I'm coming back to that technology, all of those things can be very and are readily being remote sensor monitored right now. And so it's a lot easier to really focus on some of those ships than when you're dealing with artisanal canoes out there fishing in no-take zones and things like that. So there are some tractable aspects to the enforcement in high seas MPAs. I just wanted to mention that.
Thanks, Mark. Liz, could you close this out? What's next for you on the policy side?
Yeah, well, I think as Anna mentioned in her presentation, the High Seas Treaty entered into force just last month. And so negotiators, countries have been negotiating, working on the governance and rules and institutional architecture in advance of the first Conference of Parties meeting, which will happen either sometime later this year or early January of 2027 at the latest, which will actually then start have a meeting of the decision-making body to be able to start putting some of the important ambitions that are in the treaty into practice. We know that governments, NGOs, scientists are currently working on those first generation of high seas MPA proposals, and really excited to be part of this panel and hear about Anna's science and the technology innovations that Mark was talking about, because those are important inputs into those proposals. And to know that there's more data coming online that can be incorporated now, but also in the future, because these proposals under the treaty, we'll have monitoring and review and have adaptive management. And so there will be opportunities to refine and fine tune these things moving forward as more of that data becomes available. So it's a really exciting opportunity, and I think a really important tool towards meeting those global commitments for 30% in a meaningful way.
Thanks, Liz. And thanks, Anna and Mark, for a great conversation. Now I'm very excited to turn things over to the audience for some Q&A, which will be led by Kayla. Kayla, over to you.
Awesome. Thank you. Thank you all for that great conversation. We've had a lot of questions come in, and we have little time left, so I'm going to do my best to combine some of those questions and build off of them as well, especially in areas where there were some thematic overlap with those questions. So this can go to anyone, but Anna, maybe you can start us off. There are several large collaborative programs with similar goals to MegaMove. For example, there's this program called Blue Corridors. There's Erdmann, the Marine Biodiversity Observation Network, and those are just a couple of examples. Could you talk a little bit more about how these efforts could potentially work together, where we could streamline some of this information so that decision makers can use this information effectively and also not look at these programs as competing with one another, really seeing them as resources to be able to move forward and make these really informed decisions?
Yeah, good question. Indeed, that's true. There's a lot of different programs that are looking at this now, and it's really, from my perspective, I see it as a fantastic thing. It's important that people are doing this, and there's more people looking at this from this global perspective. And although we are doing similar things, I don't think they are the same across all. So I think there's definitely space for leveraging from each other and gaining from different groups. So yeah, I can only talk specifically from the MegaMove side. So MegaMove started 10 years ago. So the scenery now is very different from when MegaMove started, and there's a lot new networks that were created afterwards. A lot of them stem from what MegaMove was already doing. So it's really exciting to see how people felt the need to look at particular taxa groups, because of course you can do a lot more in terms of depth if you're focusing on a taxa group specifically. So that was not the objective of MegaMove. The objective of MegaMove was to bring it together across megafauna species, with the idea that perhaps bringing it all together, we could unify our voice to say where is the important areas across taxa. But of course, there's a lot of important notions that MegaMove can't even try to address, things associated with different behaviors, very specific different behaviors, life stages. They are all very different across the different species that we analyze. So it is important that those groups move ahead and focus on questions that are specific for the taxa, or even specific for some species within that taxa that they are focusing on. So I see a lot of value in all of that. And then there's other initiatives that are focusing on biodiversity generally. And so biodiversity is not just marine megafauna, it includes everything that lives. So I think there's space for everything, and I think the different networks can work at different depths at the specific focus that they have. So I see that as very important. But yeah, of course, there's a lot of space for integration or to feed from each other to then leverage the outputs. And I think the key that information that should come out of it is what's the most important for particular taxa groups. So you mentioned the Blue Corridors, that's a whale cetacean specific program. MegaMove across taxa, but focusing on marine megafauna specifically, so the large animals in the ocean that do large long migrations. And then something like Erdmann, which is across everything. We can talk about many different types of biodiversity and the association with ecosystems as well. So I think there's all very different niches there, and there's space for everyone.
Yeah, I think a key takeaway for me, especially from the conversations you all were having, is this is an extremely complex, large issue. It is not going to be one person, one group that is solving the issue at hand. And it's going to take a lot of collaboration and different perspectives, different data types, and different organizations who are working towards this goal. So I think the more people that are working on this, the better. And communicating that with policymakers is essential. Does anyone else have anything else they wanted to add to that question before we move on? Nice. So throughout the panel discussion, some of you brought it up, and also many people in the audience have brought this up, that there are existing frameworks that are in place. There are existing MPAs, there are conservation targets that we're working toward, as you know, not just at local scales, but regional and global scales as well. And even with those in place, we're sort of failing to reach some of our conservation goals. I'm wondering if there are any bright spots that you all could point to, where you've seen in the past something that we could learn from for how we could strengthen these current protections. Or maybe it's an example of a roadmap for how we can use that to start new designation processes as we look towards the future, and with opportunities like the BB&J Treaty going into force and new information always coming out. Even acknowledging that, like, perhaps we have had failures in reaching our conservation targets in the past, but there are areas where we have had success. And so I'm wondering if any of you could point out some of those bright spots here.
I'll start. I think, you know, some of the bright spots are the recognition itself, right? The recognition embedded in these targets, the importance of protecting at least 30% of the world's ocean, agreed to by over 192 countries, the Convention on Biological Diversity, all the countries of the UN coming together, signed by over 196 countries and ratified now by 86 countries, the High Seas BB&J Treaty. I mean, these are building on existing targets that, yes, or existing commitments that maybe have not been met, but it is, I think, increasing the ambition and the urgency and the recognition that while we may not have done enough to date, we still need to do more. And that gives us the latitude, as civil society, to push for more, to ask for more, and try to get closer to those ambitions, and hopefully meet and exceed them.
I'll just quickly jump in. I would say, look, you know, there's an enormous number of threats facing the ocean, and we now realize that, much more so than we did 10, 20, 30 years ago. But I think when you work in this space, the only way you can work in this space is to be an ocean optimist, because otherwise you just drown yourself. I am an ocean optimist. I believe the ocean has an enormous amount of resilience built into it, simply from its size, from the fact that the majority of the animals and plants living within it have reproductive mechanisms which allow them to create typically huge amounts of offspring. And if we leave the ocean alone, if we just give it a little bit of breathing space, it tends to do quite well in recovering. And there's lots of hope spots around the world that we can look at. I'm not going to specifically name them. I have my own favorite ones, but you know, there are places which are better today than they were 20 years ago, and that can happen. It's really a matter of bringing together the stakeholders that have something to say about that area, and really working with them, and coming up with solutions. It's doable. It is very doable. It's hard work, but it's doable. And the ocean has this tremendous capacity, this tremendous resilience. So we just need to give it the ability to come back. And I think we can do that. So.
That's great. Anna, did you have anything you wanted to add?
No, I think both Liz and Mark covered it really well. So I agree. Nothing to add.
Well, I think that's a great note to end on. We are at time. So I just want to say thank you again to our panelists and speakers. Thank you to Octo for having us. I'm very excited for the turnout that we had today. Again, we'll be sharing this recording. Please spread it far and wide once you get that. And congratulations to Anna on finishing her Pew Marine Fellowship. And thank you so much for sharing your research with us today. Looking forward to the continuing conversations.
Thank you.
Thanks,
Thanks, everyone.
everyone.
Thank you.
Thank you.
Bye.